Hi guys, so today we'll be solving the Leetcode daily challenge. It states that you should be finding the missing positive. So you will be given an array, and inside this array you have to find out the first missing positive. Or we can say, if we have this array like 1 to 0, okay, what are the positive numbers? What are the positive numbers? 1, 2, 3, 4, like this, right? So what you will do is you will try to check if 1 is present. Okay, it is present. Then 2, whether it is present, it is present. 3, okay, 3 is not present. So this is your answer. Okay. Next example, you may see 3, 4, minus 1, 1. So we will again try, is 1 present? It is present. Is 2 present? No. And this array 2 is not present, right? So 2 is the answer. Okay. How can we do this? So firstly, what we can do is we will kind of take some temp variable and we will just increment the count. Okay, we will first try to find this one in the whole array. Okay, 1 to 0. So this is the array. Try to find it if it is there or not. How much time will that take? Because the array is of length n, this will take n. Okay, but the question is how long will you go for each of the element? You might have to try for all the n elements, right? How long will you have to go? That is the question. So you can see that if I am having an array of length, let's say of 0, 1, 2, 3, so this is of length 4, right? So what is the minimum missing number that could be there? Okay, let's say this is all minus 1. What is the minimum missing number? So that is 1. So that is the reason I'm starting with 1. What is the maximum missing number that could be there? So it could be 1, 2, 3, 4, correct? So the maximum missing number could be 5, that your one is also present, two is also present, three is also present, four is also present, correct? And the only missing number could be five. So how did you get this five? You can just see that it is almost like n minus one plus two, which is n plus two, right? So what is the range so of your missing number? You have a range of your missing numbers, and that is from one till n plus one. Okay, this is the range. So out of this range, you will never find any missing number. So that is the reason for how long do I have to try this? I have to try this for n times maximum. And for all the n times, I will try to kind of do a linear search, which will take order of n time. So this will take order of n square time and order of one space. Correct? Now, can we do this? Can we have a better approach to all of this? What we can do is we can try out sorting. If I try to sort out all the numbers, so that would be 0, 1, 2. There could also be some negative numbers, okay, like minus 1 could be there, okay, minus 2 could be there, and directly I have some kind of 7, 7, 9, something. Now you try, you go just iterate through all of this array. You just ignore the negative numbers because those numbers cannot ever go missing. Now, what I said, your missing numbers could be only in this range. So just ignore this, ignore this, ignore 0 also. If you go to 1, if you go to 1, you can see that this is present, right? So I was expecting my first number to be present. So it is present. What is the next number that you expect to be present? That is 2. So iterate. Okay, you have found 2. Now what is the next number that you are expecting? That is 3. So again, go ahead. Did you find 3? No. I found a different number. So 3 is not there in my array. So that is the reason I will be passing 3 as the output. So this is very intuitive approach. Now this will take order of n log n time because first we have to sort the input array and then you have to do a scan once. So this will take kind of order of n log n. What after that? What is the space? The space is order of n because sorting, as I said, merge sort, if you use, that will take order of n. Even quick sort, average case would go to log n space, and worst case would go to order of n, correct? But fine, that is all fine. You reduce the time, that is fine. Can you do better? They are asking you to do in order of n time and order of one space. Can we do that? So one thing comes into my mind is these are the numbers that would go missing, right? So first you will try to search for 1, then you will try to search for 2 if it is present in the array, then you will try to search for 3, then 4, then so and so till n plus 1, right? You will try to search for all of this, but it was taking order of n time before. Can I reduce this order to order of 1? Can I do that? What if I say, if I want to look at 1, I will try to look at the index 0, 3, and then 4. Okay, I will try to look at 0. And there should be some indication that this imagine like these indices are kind of houses. Okay, these indices are kind of houses. What if I say that, so if I take an example like 3, 4, minus 1, 1, okay, or 1, right, or 1, 2, maybe I will just delete 3. So here I can see that 4. 4 can be there in the house 3. So what 4 does is it marks this house. It marks this house. What does that say us? What does that tell us? It tells that this house or this index is claimed or somebody is living in this house, right? Somebody. So this is our house with index. Now who can live in this house? A person which is having a value of index plus 1, right? So I'm saying that 4 which is there, it actually claimed this house or is started living into this house. Okay, let's look at minus 1. See, minus 1 is not in our range, so we don't really care about it. Ignore it. Is 1 in our range? Yes. So 1 will mark 0. 1 will say that I am going to live in this house. Again, go ahead. Go ahead and see that 2 is also there. So 2 will say that I am living in this house. Okay, that's it. Now what you try to do is just iterate over all of this. You see if the house is there, if somebody is living in this house, that means my number is present. Okay, so when I say that somebody is living in the house 0, what does that mean? Somebody is living in the house 0. That means that a person 1 is living inside this. A person with the value of 1 is actually living inside this house, right? If that was not the case, this house was never could have never been marked as, to be claimed, correct? So that's fine. So that means that my 1 is present. Now if you want to check if 2 is present or not, just try to see this index. Okay, you see that, okay, this house is marked. That's it. Now go over 3. Try to search 3. Is Now how can you see if 3 is present or not? You will check the house 2. You will check the house 2. Now you can see that the house 2 is empty. That's it. That is your answer. This is your answer. So 3 is your missing element. I hope that you understand what is the intuition behind this. Of course, now we will see how to get this, okay, how to mark these houses and stuffs, right? That is what we will try to look at next. Okay, but now you understand that if you have this array, if you are given this array where each of the target elements which are there, okay, or each of the elements that could go missing, they could have a house, then we can just check, we can just check it in order of one space. Okay. One more thing that I want to point out is I'm saying for 1 to n, right? 1 to n plus 1. Let us take 4 elements, 0, 1, 2, 3. Okay. So the range would be 1 to 5, right? So 1, 2, 3, 4, and so this is the array, but this is the fourth index, which is out of the array. So what I will do is I can check for 1 to 4 whether they have houses or not, right? So the fifth five case which is there, right? I will handle it separately. What I will say is if you do not find houses for these 1 to n elements, you will end up here at the index, right? You will end up over here. And when you end up over here, you can just intuitively say that your elements 1 to 4 did not have a house, right? So that is the reason the only element which could now be a missing part is 5, right? Because it is the maximum element. Okay. So if I try to write down a pseudocode for this, what I will do is I'm imagining that I'm having this kind of, okay, I'm imagining that I'm having this kind of array right now where a house which is there, if I am saying I can have it to be claimed or unclaimed, okay, I can have it to be claimed or unclaimed. So I will just go to this array. I will go from I is equal to 0 to n minus 1, correct? And I will check if that house is claimed or if somebody is living in that house. So if somebody is living in that house, I don't have any problem. I don't have any problem. Okay, I will just go ahead. But else what I will say, if nobody is living in that house, like over here, what can you understand from this? From this diagram, what can you understand? You can see that 1 would be present, right? The only one who can be present at this house 0 is the element 1. So 1 is present. But what about 2? 2 should be living inside this house, but he is not living, right? So this is where this condition is coming, right? So the house is not claimed. So if the house is not claimed, that just means that we can return this as an answer. Okay, so we can return this index plus 1, right? Index plus 1. Why? Because at the index 1, who is supposed to live? 2 is supposed to live, right? And once we go out of this loop, by default, we will return n plus 1. Okay, this will handle and say 1 to n cases. This will handle 1 to n cases, right? If 1 to n cases are going to be missing, it will handle it. Like if you come till the last, you can see that, okay, for 3, there should be a 4, or we can say that the house which is there over here, it should be claimed by 4, but the house is not claimed. Okay, so 1 to 4 you can handle over here. But what about the fifth element? if you just go outside this, the only element that could be there right now is 5. Okay, so that is the reason why am I returning n plus 1 as a default. Now the question comes is, how will we understand or how will we make such a array where I'm saying that 0, 1, 2, 3 and 1, how can I say that let 2 claim this particular house? How can I say that? Let us take some kind of example, maybe something like 7, 11, minus 1, 0. We can make 3 as a missing element. Okay, so 1, 2, I think that is fine. So 0, 1, 2, 3, 4, 5. Let's take another element. So maybe it is something like 4. Okay, and that's it. Okay, so this is our array. Now let's just see if how can we make that array. You start from 7. You see that uh, is my 7 in the range? What is the range? Firstly, identify that. The range is, as I said, it would be n plus 1, right? So 1 to 8. That is the range that would be there. So 7, yes, 7 will happily mark the 6, okay, as claimed. Then just go to 11. Is 11 inside the range? No, 8 is a totally useless element. Ignore that stuff. Go ahead. Is minus 1 in the range? Ignore. Ignore. 1. 1 will claim this house. Go ahead. 2 will claim this house. Go ahead. 4 will claim this house. Right? So you can see that. And after that, we just go out of the bound. So which houses are claimed? If you see, 7 is claimed. This 0th one, first one, third one, and the 6th one is claimed. Right? So now if you iterate through all of these houses, you can see that at 2, there is no house. So that means which is the element which is missing? 2 plus 1, 3. Correct? So that is the intuition. Now, your question might be, still we have to mark, right? We have to mark these houses to be stored, like if that index, whether that house is taken or not, right? So that will take order of n space. But can we do it in order of 1? Yes, that also we can do. Let me take this that example once again. So 0, 1, 2, 3, 4, 5, 6. Okay, so 7 has to mark this house as taken, right? Just put a negative over here. Do not touch the value, just take a negative. That's it. Again, when you go to 1, it will just put a negative over here. When you go to 5, there is 2, you just put a negative over here. Okay. And when you go to 4, just take the absolute value. Okay. Absolute value over here. And you can check that. So negative of 0, which will be there. So you can just imagine for now, it is minus 1. Just for now, minus 1. Okay. So all of these elements which are claimed, you can see that they are negative. Okay. But then there is one problem. This problem that we saw that, when it was 0, if you do a negative of 0, it will still be 0. And what about this original negative? This house is not claimed, still it is negative, right? So what we do is, if we encounter, what we will do is we will pre-process this array. Okay. We will remove all the negatives, remove all negatives and zeros. Okay. We will remove all the negatives and zeros. But we have to replace it with a certain value, right? We have to replace it with certain value. If you saw, this 11 did not had any problem being there, right? Why? Because that 11, first of all, is a positive number and it is not in this range 1 to 8. So what if we replace these negatives? Okay, what I'm saying is, what if we replace these negatives and zeros with some kind of positive number not in the range of 1 to n plus 1? That will work, right? So what I will do is I will replace it with n plus 2. So I have the 7, 11, minus 1, 0, 1, 2, 4, right? That is, so let's just pre-process this array first. So if I pre-process this array, I will get 7, 11, this is negative, so just put maybe 9, right? So because our range is 1 to 8, only these numbers would go missing. 9, then again 9, correct? So for these two, and 1 to 4. Now do this approach. What 7 will do is make this guy as negative. What, so I will just put indices, so 0, 1, 2, 3, 4, 5, 6, okay? And because 11 does not have a home, just ignore it. Again, 9 will not have a home as it is out of the range which we only did. Ignore. For this guy, it will mark minus 7, right? For 2, it will mark this guy as minus 11, and for 4, it will mark as minus this guy. Okay. Now, what you can do, you can just iterate through this whole array. If you see a negative, that's fine. See a negative, that's fine. Oh, you got a positive. You got a positive. That means this home is not taken. And who did not take that home? The element 2 plus 1, which is 3. And that's the answer. That's it. So there are three things. First, pre-processing the array, which will take order of n time, right? And the second is you will claim the houses and stuff, right? Here, this is the claiming of the house. That will again take order of n, and then you will just iterate through the array and see, the first positive quantity that you get, right? So iterate to get the answer. That will take order of n time. So you can see you will get order of n time totally and order of one space. So this is the whole intuition. I know this is a very long problem, so that is the reason that it is a hard problem. But I hope that I have made a little bit easy for you. Let's just see the code for this thing. So this is the code. So I am just defining the range to be 1 to n, correct? And see, range of the number n plus 1 is also supposed to be in the range, right? But I will not handle it over here. If by default it is not handled, I will just return that n plus 1. That's it. Okay, that is how I'm handling it. So here, what is the first step is to pre-process the array, right? So whatever number is not in the range, this element is useless. I will just take it as n plus 2. I will just mark it as n plus 2. Why? Because n plus 2 is just not in range. And going ahead, I will not do or I will not touch anything which is not in the range. Okay. Now claim the houses of the people who are in the range, right? So again, you have to take the nums of I and check if it is not n plus 2. That means it is in range, right? But take absolute because as I said over here, you can see you can try to take minus 4, right? Minus 4 home will be minus 4 minus 1. That is how you will go. No, you have to take positive quantity, which is 4, and 4 minus 1, which is 3. That is how it will mark this guy, right? So that is the reason we will check if we will take the absolute quantity. Now we will check the home. Okay, that is the home of this particular guy, and only mark it as negative in the case where if it is already positive. It might happen that there are two fours. The first four will mark the its home 3 to be negative, and the next four which is there, it will also make it negative, and two negatives will make it positive, right? So only if it is positive, make it negative. That is why I have this check. So once you claim all the houses, just go through all the houses and check if you have a negative quantity. That means the home is already claimed. There is no problem at all. But if not, then that is the missing number, right? At that index, this at index I, you don't have that house to be claimed. So what is the missing number? I plus 1. And by default, if you do not find anything, what is the maximum positive missing number that would be there? N plus 1. That's it. So return that answer. Okay. So if I just submit this code, you can see that it is working. Okay. So thank you.